Good afternoon and welcome to the GibbsCAM probing webinar. Discover the power of on-machine probing. In the previous webinar, we talked about why we probe. Today, we're going to get a little bit more in depth about how to probe. But also, in this webinar, we will highlight datum setting just prior to machining. In other words, using your probe as an automatic edge finder. We will also talk about measuring your part and viewing the measurements in your machine called critical part feature analysis. The data flows into a table on your machine where you can actually view the dimensions of your part. We will show you how to update wear compensation values and work offsets to get your part to tighter tolerances. And we can show you how, with a little bit of macro work, you can create an inspection report after the completion of machining. While the webinar is going on, please enter your questions in the question box on the GoToWebinar control panel. You will also notice that on the control panel is a download area where you will be able to download several of the documents that will be used in today's presentation. Let's switch over to the GibbsCAM screen, and I have a bunch of probing operations here, and we're going to get rid of them all. And we are going to show you how we put a probing operation on a piece of stock. Here we have a 5-axis vertical. Let's have a look at the machine real quick so we'll know what we're looking at. It is a Doosan DVF 5000. There's the machine, the part sitting on the 5-axis table, and we will do some multi-axis probing today. But let's look at the part and the fixture, and we've already seen the stock. We're going to show you how to probe the corners of the stock using your Renishaw probe and the Renishaw Inspection Plus software that's already embedded inside of your machine. Here are the two probes that are most commonly used: the 6mm by 50mm probe and the 6mm by 100mm probe. The diameter of the ball can vary. You may buy smaller styli if you have smaller features that you need to measure. But when your machine comes from the factory, it generally comes with these two stylus, the 6x50 and the 6x100. In GibbsCAM, you can create this tool very easily. Here are the dimensions if you'd like to snapshot this screen. And then you can save them to your tool list. Once you create a tool in GibbsCAM, you never have to create it again. I want to take a quick moment to make sure that everybody can see. Yes, everybody can see and everybody can hear, so let's continue. Let's bring the probe down into the process list and select corners. In GibbsCAM, we have the ability to probe the stock corners, the stock that's called out here in the document control page. If we want to probe other stock bodies, we will show you how to do that also. But this is for the corners of the stock size and part origin. And it's almost fully automated. Here, we type in the feed rate that we want to use to approach the part. The probe touch time is simply a number that you assign to this operation, so that when you go to Operation Manager and look at your summary, you can see the time is considered in your total cycle time. We're going to clear the part by 0.4. And once we get inside of 0.4, we will go at a slower feed rate. Renishaw does that automatically. We're going to measure an outside corner, and we're going to set work fixture 1. Our XY clearance is 0.4, which is a short way of saying 10 millimeters. In your Renishaw Inspection Plus software, 10 millimeters is the standard offset distance. I want to probe the lower left-hand corner with 2 touches. This 2-touch doesn't change what happens in your machine, but it does show a single touch or a 2-touch cycle here in GibbsCAM if you want to save time with single touch. How far from the corner do I want to measure? My X distance of 1 and Y distance of 1. I will measure 1 inch up and 1 inch over. And my Z distance is to the center of the ball. I'm going to make this minus 250 because the ball is 236, and I want to make sure that the ball gets below the outside of the stock. When we click Do It, we get our first probing cycle. Let's look at it in Machine Sim and see what it looks like on the machine. See it before you machine it is always the best way to review your CNC process. We measured X and we measured Y, and we set X and Y in this coordinate system to that coordinate of that corner. Now we need to do the Z as well. Change from outside corner to single surface from corner Z. The top of the stock is at 0. It's already been precision faced off. So we're going to set the probe depth at 0. When the probe touches the top of the stock, we want it to be set to 0. This is a single surface corner, XY clearance 0.4, 2-touch, lower left corner, Z axis, and always from positive side. It would be kind of difficult to probe this from the negative side. And of course, we're in the XY plane. When we click Do It, we now have 2 probing cycles. Let's watch both of them run now let's change that to OpSim and rewind. And you will see corner 2-touch, corner 2-touch, and top. We just set that corner to these coordinates. You don't have to set your corner to 0. GibbsCAM and the Renishaw probe know that 0 is going to be over here, the distance from this corner. And you can see the distance is, X is minus 4.65 and Y is minus 4.68663. So don't worry about that. GibbsCAM and Renishaw will set your coordinate correctly. You can duplicate this for each additional corner simply by opening the first op, change to the upper left corner, click Do It. You've got a probing cycle. Double click Op 2, change to the upper left corner, click Do It. And you can do that all the way around the outside of the stock with very little effort. The probe is a very accurate measuring device that most people only use as an edge finder. Here, we are teaching you how to use it as an edge finder. A little bit later on in the webinar, we'll talk about measuring your parts and even updating the wear comp on your tools. Here, we're talking first about datum setting. And of course, let's review that. Datum setting is with work fixture or work plane. We're using work fixture. And we're doing corners right now. We do the outside corner and we did the Z. Once you automate this, every time your operator puts a new part in the machine and closes the door, you have created a predictable, automated process that does not make mistakes. Your probe's accuracy is 40 millionths of an inch if you have the standard probe. If you purchased the improved accuracy probe, which is a CMM quality probe, your accuracy is 10 millionths of an inch. So the probe is much more accurate than your machine. Let's move ahead a little bit and talk about probing other types of features. Remember, this webinar leans a little bit more towards how do I probe rather than why do I probe. The first thing that I would like to look at is let's measure this bore and this boss right here. And we're going to use that feature to set our 0. Bring the probe down. Select now, instead of corners, we will select shapes. We will set our feed rate at whatever your machine can tolerate or whatever your machine is programmed at from Renishaw. I'll put 4 seconds in here for cycle time. The standard Renishaw standoff distance of 0.4 and 0.4. And let's do circular pocket first. Do we want to set work fixture or measure? We want to set work fixture. And let's set work fixture 1. 2 touch. Probe depth, I want it to go just inside of this bore. 118 would be the center of the ball. So we said minus 0.125, and this will be a 4-point measure. Turn on your profiler because you do not need to extract or create any geometry, and click the Do It button. We now have a probing cycle inside of that bore with just a few clicks. Let's have a look at that cycle by itself, but first we need to set the part to stock. Click on the part, right click, body type is stock. Now when we go back to OpSim and press rewind, we will see the part, and let's select here, skip unselected ops. That way we don't have to watch the corners. Let's probe the bore. 1, 2, 3, 4. It just probed that bore very quickly, and it output the dimensions of that bore to your offset table, which means that this is going to be the center of your part. The probe and the GibbsCAM software, all of this happens automatically. Here we have a probing post, and we're going to output the code to this folder and click Process. Here you will see very neat, very clean Renishaw code. If you've written any of this by hand, you'll recognize it, and it's very, very easy to understand, especially when you have your Renishaw Inspection Plus manual in front of you. There we have a little bit of code, and we measured that bore. Let's change up and measure the boss now. Double click the process. We can simply reuse it. It has almost everything we want, except we'll change this from circular pocket to circular boss. Select the outside boss geometry and click Do It. Again, we have a cycle that looks very different from the circular pocket cycle. It knows to step up and over the boss when it's doing the measuring process. Notice that while GibbsCAM is measuring your part, it puts a little star on the part to show you where the probe touched. Again, we have just set the work fixture offset using that feature. That feature may have been pre-machined, and then we want to accurately set its distance to the center of the part. Now that we've looked at circular pocket and circular boss, let's look at single surface. In single surface, the only geometry that you need is a point. We have a point here, we have a point here, and we have a point here. The interesting thing about these points is when we go to single surface and we have our probe depth for Z, we're going to single surface, axis is Z from positive side. What is our probe depth? Well, we're not quite sure. We can alt click on that point and GibbsCAM automatically puts the number here. We click, check our parameters and do it, and we now have a Z probe, a single surface probe, right on the edge of that D hole. And we're going to come back and measure that D hole in a little bit because we all know the challenges of a hole that is shaped like a D. But let's go probe a couple of other Z points. Here, very quickly, we'll change the Z probe depth with the Alt key to 0. Click the point and press do it. We have another probing point there. Let's check this one's Z point. It is also at 0. Simply click on it and press do it. It's very easy to create probing code, and the code doesn't need to be tested. The code is tested right here in a virtual environment, and you can be assured that when you go out to your machine that everything is going to work correctly. You have visual verification that your probe is doing what you want it to do. Speaking of which, the new probes are much smarter than the old probes. When GibbsCAM puts your probe in the spindle, the software checks the battery condition of the probe. It makes sure that the probe is hot and running. It makes sure that the skip signal is hot and running in your machine. And it ensures you that your machine will be ready to probe if you don't get any alarms at the beginning. We just probed a couple of circular features. Now we have another circular feature over here that's quite a bit different. It's a D hole. And as you can see on the D hole, it has a little D shape. I extracted the complete circle because we need the complete circle when we're going to measure that hole. But what do we do about this position right here? If I click there, that's a disaster waiting to happen. You're going to get an alarm at the machine. It's going to say not found. And let's make that depth a little bit better. We got minus 375, and we'll make that minus another 125 and redo. But when we get to that point, that's going to make a horrible mess. And in GibbsCAM, watch what it shows you. When we go to measure the part with that D hole and the cycle is incorrect, let's click here, which is skip unselected ops. Oh, it went all the way into the material. Not good. We get to see that. What can we do about this little situation? Let's change to 3-point and set our angles to 0, 120, and 240, and click redo. Now we have avoided that D feature. Let's have a look at the cycle again, rewind and play. And the probe now very deftly avoids the D feature. You can rotate your circle to any degree by using these 3 points. The only rule that you must abide by is the same rule that you have in your CMM lab, is that the circle that you measure here must have at least 185 degrees of included angle. If you don't have that much angle, your probing application will not be correct. We know this from practice with all types of probes and probing systems. We need to pass that second quadrant. Now, let's look at rectangular features. We have a rectangular boss and a rectangular pocket. Let's change cycle type to rectangular pocket. Probe depth, let's find out the roof of this. It's at 0. We'll make the probe depth minus 0.125. And we get to select X and Y, X only, or Y only. Let's do X and Y and do it. Whoops, I didn't click on the geometry. Turn on the profiler, click on the profile geometry, and redo. So I clicked the wrong geometry, and it will show me that when I run the cycle, it will show me that this cycle will run clear through the material. We simply need to click the inside geometry and redo. GibbsCAM will show you when you've made a mistake. When we go to OpSim, rewind and play, we now see that the probing cycle is correct for that inside rectangular pocket. We'll skip this rectangular boss because we pretty much know how it works. Let's do something a little bit more exciting. Let's go work on this rectangular boss, which is rotated at an angle, and an angle that we have no idea what it is. We can measure it by extracting geometry. or any number of things, but GibbsCAM and Renishaw can figure out the angle for us automatically. Rectangular boss, probe depth, X and Y, select the geometry and press do it. And what do we get? Oh no, that looks horrible. That's terrible. Why didn't the software recognize that that was a skewed rectangle? Because Inspection Plus does not have that ability. We have to create a new coordinate system. And to do that, we created a coordinate system. We click on the geometry and click redo. And now you can see that whoops, no, it has not. It has not straightened itself up. What do we do about that? We change our machining coordinate system. Change it to rotated coordinate system and press redo. Now the probing cycle, when we click the geometry, will be rotated at the correct angle to measure this part. And it will also return the angle of that part, and it will put it in an offset register, a macro variable register inside of your machine, and you can read that for yourself. So we've talked about probing all of these different features, circles, pockets. Let's talk about probing a single line. Do I need to extract a single line to probe on the left side of this part? No, GibbsCAM automatically knows. Go back to single surface, and this will be X from negative side. The depth is good, the clearance is good, everything looks good, and we're in the right coordinate system. Click do it, and it measures the left side of the part. If we want to measure the right side of the part, click over here, click from positive side, and do it. We now are measuring from the positive side of that line. Let's switch up and go to the y-axis because we only have a very tiny line there from negative side, and GibbsCAM and Renishaw can find that line for us. Let's look at those last couple of operations together in OpSim and selected ops only, where we have a skewed surface. First, we have the outside boss. Then we do a single surface, and single surface. We've brought to you a large amount of capability in measuring and finding your parts. But what about cutting your parts to a tighter tolerance? Let's say that this bore has a very, very tight tolerance. What we would do with this bore is we would machine it first and leave 5 thousandths worth of stock and then measure it. Let's do just that right now. We're going to measure that bore. Circular pocket, depth, bore point, but now instead of setting work fixture, we're going to measure. And if that bore measures 1 thousandths outside of the tolerance range, the machine will automatically stop and alert the operator that this part is out of tolerance. If the part is in tolerance, we would continue on with the finished cut. Let's have a look at that operation by itself. This operation is missing something. Let's post the previous op and this op so that you can see the difference between them. Notice that this op on the probing measure line, it has an S1 value. That means that it's going to set work fixture 1. Down here, there is no S1 value, but there is the H tolerance value. If you want to output the deviation of that circle to your wear comp table and have the Renishaw probe in GibbsCAM update your wear comp automatically, simply put the T number behind that line. When you put T3 right there, that will automatically add the deviation to your wear comp, and then you create a finish op for that bore, and you have cut that bore to the tightest tolerance that your machine can achieve. We call this cut, measure, cut technology. And in cut, measure, cut technology, if your machine has a total tolerance capability of 0.4 of an inch, then the Renishaw probe will help you get to that 0.4 of an inch without opening the door, climbing in the machine, measuring the part, coming back out, going to the wear comp table, adding the numbers in. We have interrupted the program by stopping and having someone measure. By using GibbsCAM to automate your probing, all of this happens automatically and reliably and without detriment to your cycle. Your cycle becomes much more predictable. The machine heating and cooling becomes much more predictable on very tight tolerance parts. We've looked at measuring the part in a number of different ways. Let's see what other options that we have here under measurement. We can alarm if it's oversized, but let's say the bore is undersized and we don't want an undersized alarm. We just say continue, because if a bore is undersized, that means that it is in a material on condition and we can continue machining. Only if the machine is oversized would we have, or the machine bore is oversized, would we have a problem with a bore. Now, a boss is exactly the opposite. We would leave its alarm for undersize and continue for oversize. All of these little tricks help you create a more accurate, more reliable program. It helps you slash setup time. It helps you reduce your lead time, reduce your process variability, reduce scrap and concessions to your customers, and to make your process more predictable. You can measure your parts after you're done, and when you output that measurement, where does the measurement go? If you look in the programming manual of your machine, you will see where the outputs go. On a Haas, the diameter would go to parameter 138. There are a number of handouts that we have for you in the downloads area, and those are things that we have just talked about, things that we do just before cutting, things that we do during cutting, and things that we do after cutting. You can simply click on those links to download those documents. These documents give you a problem, they give you the solution, and they tell you what the benefit is of using the probe in an automated fashion inside of your machine. Each of these documents also includes a case study and shows you what the code is going to look like when it comes out to your machine. This is Step Application Protocol 203. You've seen this many times when you import a solid model. Step AP 203 simply means datum setting. Step AP 301, cutter parameter update. Remember, we showed you that adding a T3 to the end of that probing line will automatically update the wear comp of your tool. It gets even smarter than that, because the wear comp for a Z feature is different from the wear comp for an XY feature, but the software automatically knows that information. The last thing that we have here is another document that says critical feature reporting. You want to be able to look at the dimensions of your part and alarm your operator if the dimensions exceed you have a lower tolerance band and you have a fail band here. You have a lower tolerance band, an upper tolerance band. That's the warning, is yellow, and red is a failure. And the machine will stop automatically when you get to the failure. We hope that you have enjoyed the how-to section of this probing exercise. We're now going to switch over to Mr. Bart Ehlers, and he's going to take any questions that you might have.
Hey, Patrick, thanks a lot for once again doing a great job showing the benefits and the power of doing on-machine in-process probing. Lots and lots of value there, and hopefully a lot of the customers are already doing it, and they want to increase that power by getting GibbsCAM, or if they're not, hopefully we've shown them enough benefits that they'll want to discuss it. We do have a few questions to go through, so let's start with the first one. Can GibbsCAM probing adjust the tool wear compensation on my machine?
Yes, it can do tool wear compensation on your machine. And if you have a Siemens control, a FANUC control, and when I say FANUC, we mean FANUC clones as well. FANUC clones are, of course, a FANUC is a FANUC, but you have Mazak, you have the Moriseki MSC, you have the Mitsubishi 700 series, and we also have some other FANUC clones out there. We talked about Mazak. Oh, the Makino Pro series is also a FANUC clone, and they all use almost identical the same software. And yes, that wear compensation can be automatically added to the cycle, and it runs each time you run a new part.
Okay, great. Another one from our audience. Is it possible to probe non-prismatic surfaces?
With the standard switch probe, the answer is yes, but with greatly reduced accuracy. If you want to probe non-prismatic parts, you will need to step your probe up from the OMP 40 or OMP 60. That's a 40 millimeter head probe and a 60 millimeter head probe. You'll need to step up to the OMP 400 probe or the OMP 600 probe. Those are actual strain gauge probes that are Ren gauge CMM quality probes. And they not only can sense direction much better than a standard probe, they are 4 times more accurate. So the answer is, if you want to do prismatic, non-prismatic probing, you'll need to step up to the more accurate probe.
Okay, great. Another one, let's see. When probing on a part and running machine sim, if the codes are wrong, it's not alarming out with any messages. Will it alarm out with an actual message?
On the machine, yes. Here's what happens. If the operator loads the part incorrectly, and we're going to talk about incorrectly in a number of ways. If he loads it too far, we talked about that lower left-hand corner. If he loads it too far to the left and the probe comes down, it will approach the part, and because the top of the part is now where the part was supposed to be, was not supposed to be, it will feed down, and when it touches the top of that part, it knows that the top of that part is not supposed to be there. And it will alarm out, and it will say, path obstructed. Now, on the other side of the coin, if the operator loads the part too far to the right, and let's say he loads it a half an inch or a quarter of an inch too far to the right, Renishaw and GibbsCAM will search for the part within a certain range. And if they don't find the part within that range, it will also alarm, and it will say probe is open, which means that the probe didn't find anything. And that's, again, a signal for the operator to stop and go in and push the part up against the stop and restart the program. So yes, if the probe runs into anything that's not supposed to be there, it will alarm and say path obstruction. If the probe goes to find something that's supposed to be there and it doesn't, it will alarm out and say probe is open. So yes, you have both found and not found conditions where you will get an alarm.
Okay, and that's on the machine side. How about in the software side? Is there any kind of graphical feedback that would tell the programmer, the user of GibbsCAM, that, hey, there's an issue? Maybe, like, for example, you showed a few errors there where you selected the wrong side of the geometry or the feature to probe, and it was forcing the probe through the material. Is there, other than the, seeing it in the simulation, which you'd have to be paying attention to and see, is there any other kind of graphical feedback within the software?
There is no other graphical feedback in the software when you are probing in GibbsCAM, other than you look at the probe cycle and you see those little stars. You simply make sure that those stars are on the surfaces.
And that's what I was getting at, is those stars show you where it's touching and where it's approaching from. So if you see it approaching from the wrong side and the star on the other side of the feature, you know that you have an issue then. Okay.
Absolutely.
Okay, here's one that I will take. Does this require an updated post processor for output? Yes. You can take any existing posts that you have, and they do need to be upgraded to have probing support added to them. To do this, simply contact your GibbsCAM reseller, and they'll work with you to go through the process to get your post processor upgraded. Let's see. Got a few here. Does Gibbs write a macro if the part probes out of tolerance of the machine part after it updates the offset table?
Ask that question again, please.
Sure. Yeah. Does Gibbs write a macro if a part probes out of tolerance to remachine the part after it updates the offset table?
Let's go
back.
back.
Not clear about that. That's okay. We can. Oh, I'm sorry. Go ahead.
Yes, your post processor can be configured so that when you create a semi-finish operation, a probing operation, and a finish operation, if the part is within tolerance, you can specify a go-to block, and we would do that go-to block by selecting utility ops and go-to. And we have a go-to target we'll set down here, go-to target here. That is our target. And then we would say up here, if we measured the part, single surface, measure the part, and if it's undersized, alarm. If it's oversized, then go to target 1. The answer is yes. We can create go-to segments that will steer the probe or the tool around an operation that either, number 1, it needs to be cut, or number 2, it doesn't need to be cut and it can skip over it.
Okay. Another question. Can a user still use their own programming cycles that they created in the past?
Yes. We made a special provision for customers who may have invested money in a probe macro. Let's select a probe here. If you have a huge probe macro or any probe macro that you've customized and made your own, you can simply paste it right here, click the do it button, and you now have an operation that has your custom probe macro in it. The only caveat here, as you can see down here in red, is that warning, raw G code added to a program will not be validated or simulated by GibbsCAM. But yes, you can use your previous investments in probe macros, paste them right here, and create an operation out of them. Okay. And there it is.
Now we have two. Well, now we have two very similar questions. I'll just ask the first one. If I currently have P+, can I also use the new GibbsCAM probing?
Yes, you can. Both Productivity Plus, Renishaw Productivity Plus, and Renishaw Inspection Plus can reside in the same machine at the same time. They were made to do that. Productivity Plus is a much higher level program for much more rigorous and demanding applications, but GibbsCAM covers the basics of datum setting, cutter parameter update, and critical feature reporting. Productivity Plus can go way, way, way beyond that. And yes, both of these can be resident in your post at the same time, and they can be resident in your machine at the same time. And they do not interfere with each other, and they do share the probe calibration data. One set of probe calibration data for Productivity Plus and Inspection Plus.
Okay. Here's one that I think I can take, Patrick, but you back me up in case you want to expand on it. And that is, if I need more probing functionality that's available in the new GibbsCAM probing, is P Plus still available? So the short answer to that is yes, it's still available. The longer answer to that is P Plus is reaching an end of life cycle, meaning they're stopping development on it. But it's just because they stopped development on it doesn't mean it's not available, doesn't mean it doesn't still work. It's still there, it's still available, it's just frozen where it is in time. And as that phases out, the development plan is to continually increase GibbsCAM probing to fully take over all the functionality that's currently available in P+. But for now, the answer is P+ is still available if you need more programming, more robust probing capabilities than GibbsCAM probing currently offers. Anything to add to that, Patrick?
No, you hit it right on the head. I'm just, but while you're answering those questions so expertly, I'm just playing and creating little probe cycles here.
Okay, all right. Let's see. We got this question. We've got two more questions we'll do. How do I switch from P+ to the new probing? I'll let you take that, Patrick.
All right, switching from Productivity Plus to the new probing requires very, very little effort on your part whatsoever. The only thing that you need to do is to invest in the GibbsCAM probing option. And then number two, you need to have your post processor updated for GibbsCAM probing content. Just those two things.
Right, and then as we already answered in a previous question, we can capture a bunch of your probing cycles that you've already developed inside the GibbsCAM probing. So you're right, it's really just a matter of the process to switch from P+ to GibbsCAM probing is really just a matter of a purchase issue. And again, if this is something that you want to explore, contact your GibbsCAM reseller. All right. Let's see. We'll do one more question. This one here, it says, can the OTS tool setter be programmed in process for tool setting before machining ops? And can broken tool detection before? Oh, say that again. I'm sorry, Patrick, I interrupted you.
No, it certainly can. And what you will do is you will go into your basic probing cycles, and that's going to be G65 P9851, I think it is, which is broken tool detection 9851, 9852. You simply put that right into your program at the beginning, and you'll notice that you have to have just a single piece of geometry to create one of these operations, but I'm going to put it right there at the top of the program. And you'll see that when we post this, if you had, let's expand on this a little bit more. Let's put the tool in here. Let's do T1 M6 and then G65 P9851. Now let's copy this and let's paste it a couple times. Paste, 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 and change this to T2, T3, and T4, and redo. Now that you have done this operation, when you go to post it, at the top of your program, you will see the first thing that happens is all of your tools that you listed in that operation will get probed. Just like
Fantastic.
that.
Okay. Well, I'll tell you what, we're going to go ahead and wrap this Q&A session up now. There are some questions that we may not have gotten to. If you do have questions, again, just contact your local reseller, and they will certainly address any questions about probing that you have. So I just want to say thanks to everybody for attending the webinar and all the great questions. And we appreciate you taking the time and let us know how we can help you implement probing if you're not already, how we can implement probing for you. So once again, you can take advantages of the many, many productivity benefits of doing in-process and on-machine probing. So with that said, this concludes the webinar.